In a world obsessed with speed, quarterly profits, and instant delivery, the idea that a single wristwatch can take close to a year to complete feels almost rebellious, and yet that is precisely the philosophy behind a Rolex. The question is not simply how long it takes, but why it takes that long in an era where automation can produce complex electronics in minutes. The answer lies in a manufacturing ecosystem spread across 4 highly specialized Swiss facilities, each operating with microscopic tolerances, proprietary metallurgy, and a culture that treats timekeeping as both science and art. What emerges from this system is not just a watch, but a carefully orchestrated sequence of roughly 900 distinct steps, many of which are invisible to the end wearer yet fundamental to the promise printed on every dial. The journey begins at Plan Les Ouates, a vast architectural statement of glass and steel that houses Rolex's case manufacturing, bracelet production, and even its own internal gold foundry. While most luxury brands outsource alloy production to specialized metal suppliers, Rolex melts and formulates its own 18-karat yellow, white, and Everose gold on site, ensuring total control over color stability and structural integrity. This is not branding theater but metallurgical precision, because subtle shifts in alloy composition influence hardness, polish retention, and corrosion resistance over decades of wear. Massive induction furnaces glow white-hot as raw gold is combined with carefully measured elements, and from those molten crucibles emerge ingots that will eventually become bezels, case middles, and bracelet links machined to tolerances measured in microns. From there, blocks of metal are shaped by advanced CNC machines, capable of carving out intricate geometries while maintaining extraordinary dimensional consistency. However, automation is only the beginning of the story rather than its conclusion, because once the machines complete their passes, human hands take over for polishing, brushing, and finishing that must be visually flawless under magnification. The interplay between satin brush surfaces and mirror-polished chamfers is not merely decorative, but defines how light interacts with the watch, and achieving that interplay requires painstaking repetition. A single oyster case may pass through multiple polishing stations, each refining edges that must remain crisp yet smooth, sharp yet comfortable against the skin. While cases and bracelets are crafted in Plan Les Ouates, the mechanical heart of the watch is born in Bienne, where more than 2,000 employees focus almost exclusively on movement engineering and assembly. Here, hundreds of components thinner than a human hair are produced, decorated, and inspected under microscopes before they ever touch each other. The beating heart of many modern Rolex calibers features the proprietary Chronergy escapement, an evolution of the traditional Swiss lever escapement designed to improve energy efficiency by optimizing the geometry of the pallet fork and escape wheel. Even tiny changes in tooth profile or lever angle can increase power reserve, but those improvements demand manufacturing tolerances that approach the limits of industrial feasibility. One of the most celebrated innovations inside these movements is the blue parachrome hairspring, crafted from a niobium zirconium alloy that offers exceptional resistance to magnetism and temperature variation. In a world saturated with magnetic fields from smartphones, speakers, and electronic devices, traditional hairsprings can become destabilized, leading to timekeeping errors that accumulate silently. Rolex's solution was not to shield the movement alone, but to redesign the very component responsible for oscillation stability. The resulting hairspring, oxidized to achieve its signature blue hue, maintains concentric breathing even under stress, which translates into greater long-term accuracy and durability. Powering the movement is the perpetual rotor, a self-winding mechanism that converts the natural motion of the wearer's wrist into stored energy within the mainspring barrel. Though the concept of automatic winding is more than a century old, Rolex continually refines the efficiency and robustness of its rotor system so that minimal wrist movement can maintain full power reserve. Supporting this architecture are Paraflex shock absorbers, engineered to protect delicate pivots and balance staff components from sudden impacts, because even a minor shock can disrupt precise tolerances if not properly mitigated. Every protective measure built into the movement represents years of incremental improvement rather than marketing invention. Meanwhile, at Shinborg, attention turns toward aesthetics that must meet the same technical rigor as internal mechanics. Dials are not simply printed plates, but layered constructions involving lacquering, sunburst brushing, galvanic treatments, and the careful placement of applied hour markers. When gemstones are involved, gem setters work under magnification to position each stone with symmetrical spacing and exact alignment, because even a fraction of a millimeter misalignment can disrupt the harmony of the dial. Luminous materials are applied by hand with syringes that dispense precise quantities into each marker cavity, ensuring uniform glow intensity across the entire face. The final stage of the journey occurs in Le Local, where certification and quality control dominate the workflow. Each completed watch undergoes rigorous chronometric testing beyond standard industry certification, including in-house evaluations that measure daily rate variation under real-world wearing conditions. Temperature changes, positional shifts, and power reserve depletion are simulated to ensure consistency within strict tolerances. Water resistance is tested in pressure chambers that replicate depths far beyond everyday exposure, reinforcing the brand's reputation for reliability in professional diving and exploration contexts. What stretches this process toward a full year is not inefficiency, but cumulative inspection, refinement, and controlled pacing, because parts cannot simply move from one department to another without verification. Components are tested before assembly, tested during assembly, and tested again once integrated, forming a quality assurance loop that catches microscopic deviations before they become macroscopic problems. In a mass production paradigm, speed is the metric of success. But in Rolex ecosystem, stability and reproducibility define achievement. The repetition may appear redundant from the outside, yet it is precisely this redundancy that underwrites confidence in performance decades later. Even the smallest screw inside a movement is produced with careful alloy selection and surface treatment to prevent corrosion or thread fatigue over time. Lubrication points are calculated to minimize friction without attracting excess dust, and oils are applied in measured droplets smaller than visible grains. Watchmakers undergo years of training to develop muscle memory capable of placing these droplets with consistent precision, because over-lubrication can be as detrimental as under-lubrication. When multiplied across hundreds of components, these micro-decisions extend production timelines but compound into long-term reliability. Rolex insistence on vertical integration amplifies the time required for each piece, because reliance on external suppliers could accelerate production but would dilute control. By managing alloy formulation, machining, finishing, movement assembly, and testing internally, the brand compresses risk at the cost of speed. This structure also allows iterative design improvements to be implemented quietly, sometimes without fanfare, because adjustments can be made at the source rather than negotiated across supply chains. Over the course of a year, a single watch may represent not only the execution of a blueprint, but the culmination of ongoing refinements invisible to consumers. The perception of scarcity often surrounds Rolex, yet scarcity in this context is a byproduct of controlled throughput rather than artificial limitation. When each unit passes through nearly 900 distinct checkpoints, scaling production infinitely would undermine the very premise of consistency. Maintaining high output while preserving microscopic tolerances requires balancing workforce expansion, automation investment, and quality assurance, all of which are carefully calibrated rather than aggressively maximized. As a result, the timeline reflects both craftsmanship and deliberate operational discipline. There is also a cultural dimension embedded in this timeline, because Swiss watchmaking traditions emphasize apprenticeship, patience, and intergenerational knowledge transfer. Experienced watchmakers mentor younger technicians, passing down subtle tactile cues that machines cannot replicate, such as the resistance felt when a component seats correctly or the faint acoustic feedback of a properly adjusted escapement. These intangible skills evolve slowly, reinforcing why acceleration is not always compatible with mastery. When combined with proprietary materials, science, and relentless testing, the human element becomes inseparable from the calendar year it takes to complete each watch. Ultimately, the reason Rolex takes approximately a year to produce a single watch is not tied to a single bottleneck, but to an interconnected philosophy that prioritizes durability over immediacy and resilience over novelty. From molten gold at Plan-le-Ouat to microscopic balance adjustments in Bienne, from dial artistry in Cherbourg to pressure testing in Le Locle, every stage compounds into a deliberate march toward precision. The 900 steps are less a marketing statistic than a structural reality born of vertical integration, proprietary engineering, and uncompromising inspection. In a marketplace that celebrates speed, Rolex embodies a counterargument, suggesting that true mastery of time cannot be rushed because the instrument designed to measure time must first withstand it. When people hear that a single Rolex watch can take close to a year to complete, they often assume that figure is exaggerated for marketing drama. But the reality inside Rolex 4 integrated Swiss facilities reveals a level of vertical control and microscopic precision that makes 12 months feel almost inevitable rather than excessive. At Rolex, time is not simply measured. It is engineered, stress-tested, chemically refined, and certified through an industrial ballet that spans metallurgy labs, robotic machining cells, hand assembly benches, and chronometric testing chambers distributed across Plan-le-Ouat, Bienne, Cherbourg, and Le Locle, each site performing a specialized role that feeds into a production ecosystem designed to eliminate variability at every stage. The journey begins in Plan-les-Ouat, where Rolex operates its own foundry to create proprietary gold alloys that behave differently from standard market gold because the brand refuses to rely on third-party suppliers for critical materials, instead melting, mixing, and casting 18-karat yellow, white, and Everose gold in tightly controlled conditions that allow chemists to manipulate trace elements for color stability, hardness, and long-term luster retention. By producing its own gold alloys in-house, Rolex avoids inconsistencies that could affect machining tolerance or long-term durability. And this metallurgical autonomy feeds directly into the machining lines where cases and bracelets are carved from solid blocks using multi-axis CNC systems that remove microscopic layers of material while maintaining tolerances measured in microns rather than millimeters. The steel models, often mistaken for ordinary stainless steel, are crafted from oyster steel, a proprietary variation of 904L stainless steel that is significantly more corrosion resistant and more difficult to machine than the more common 316L steel used by most of the industry, which means tooling must be more robust and machining cycles longer, contributing both to production time and to the distinctive density and sheen that collectors immediately recognize. Every case passes through a sequence of finishing stages that alternate between machine-driven brushing and hand-applied polishing, with skilled technicians using felt wheels, abrasive pastes, and visual inspection under magnification to ensure that lugs transition seamlessly into flanks and that mirror-polished chamfers do not bleed into brush surfaces. While cases and bracelets are formed in Plan-les-Ouat, the beating heart of the watch comes to life in Bienne, where more than 2,000 employees focus on movement manufacturing and assembly, working within sterile environments that resemble semiconductor labs more than traditional watch workshops. Here, plates and bridges are stamped, milled, and decorated with Geneva stripes or perlage, not merely for aesthetics, but to reduce friction and trap microscopic dust particles away from critical gear trains, ensuring that mechanical stability is maintained across decades rather than years. One of the most critical components produced in Bienne is the blue parachrome hairspring, a delicate spiral crafted from a niobium zirconium alloy that exhibits remarkable resistance to magnetism and temperature variation, two invisible enemies of mechanical accuracy that can distort timekeeping in ordinary watches. The hairspring is oxidized to achieve its distinctive blue hue, but that coloration is not decorative. It is a byproduct of a controlled process that enhances its structural integrity and long-term resilience, enabling the oscillator to maintain stable amplitude even when subjected to environmental shocks. Equally transformative is the chronergy escapement, an evolution of the traditional Swiss lever escapement that improves energy efficiency by optimizing geometry and reducing contact surfaces, thereby increasing the amount of stored energy that actually reaches the balance wheel. The geometry refinements might appear subtle on paper, yet they allow Rolex movements to achieve higher precision standards while preserving power reserve, a balance that requires years of research, prototyping, and micro-adjustment before a single production unit is approved. Energy replenishment within the watch is handled by the perpetual rotor, an oscillating weight that converts wrist motion into stored mechanical energy. And while automatic winding systems are common in modern watchmaking, Rolex's implementation focuses heavily on long-term durability and bidirectional efficiency. Each rotor pivots on high-performance bearings that are tested for thousands of rotation cycles to simulate years of wear, and the winding mechanism must deliver consistent torque without generating excessive friction that would reduce amplitude in the escapement. Shock resistance is addressed through Paraflex shock absorbers, which protect the delicate pivots of the balance staff from sudden impacts that would otherwise cause deformation or breakage. Rather than relying solely on industry-standard solutions, Rolex engineers designed Paraflex to provide improved energy absorption while maintaining positional stability, ensuring that a drop or sharp knock does not translate into catastrophic misalignment within the movement. As components are assembled, trained watchmakers place hundreds of pieces thinner than a human hair into layered structures that must align with near-perfect concentricity, because even a slight deviation can amplify into measurable timekeeping errors. Assembly is not a single continuous act, but a sequence of sub-assemblies that are individually tested, dismantled, cleaned, re-lubricated, and reassembled to guarantee that no microscopic debris remains within the gear train. A level of redundancy that dramatically increases production time, but simultaneously reduces long-term service variability. In the end, the extended timeline reflects a manufacturing philosophy rooted in vertical integration, material autonomy, and relentless testing, where each facility acts as both a specialist and a guardian of standards that cannot be compromised for speed. The watch that emerges from this process is not simply assembled, it is cultivated through a network of engineers, metallurgists, machinists, gem setters, and watchmakers whose collective expertise transforms raw alloy and microscopic gears into a self-contained mechanical ecosystem designed to measure time with unwavering consistency. Understanding the 900 steps behind a single Rolex reframes the perception of cost and scarcity, because what appears as exclusivity at retail is in reality the byproduct of an uncompromising production model that prioritizes endurance over acceleration. When someone straps on a Rolex, they are wearing the result of thousands of human decisions, countless inspections, proprietary alloys forged in-house, and a year-long journey across 4 Swiss facilities that treat every second not merely as a unit of time, but as a standard to be perfected.